Okay, that's good. All right, so we're recording now. We're gonna learn about circles with special right triangles. So if I were to take a circle, and so this is just kind of, you have circles and triangles together, and then they give you kind of tricky problems there where you have to put things together. So say I make a circle with this thing coming off here, and this thing coming off here like this, and then you're told, oh, I'm not done yet. And then they'll put this here, and they'll put this to here, even though it doesn't, oh, I'm not doing very good. It's hard to see from this thing. And this here, these are both tangents, guys. And they tell you that this is 120 degrees. And then they tell you that this is 8 inches or something like that. And then they'll say, find the, oh, I don't want to erase that. They'll say, find the shaded area. Yes?
Yeah, it's not a triangle though.
Oh, it's not a triangle.
No, it isn't. No, it's a kite.
It's
you
a
can
kite.
cut it into a triangle.
Okay. So they'll give you a problem like this, but we're going to make some triangles, right? Find the shaded area. Could you do that?
Yes.
It's not as easy as you may think, okay? But what I would first do is cut this into, put a line down here, right? Would you do that? I would do that. You know why I would do that? Because that would be a 60-degree angle, and this down here has to be therefore because it's a tangent line, because it's tangent to the circle. And this over here would be a 30, right? So that must mean, since this is 90, this is 8, that must mean that the radius of this circle is something. Oh, it is something.
No, that 8 should be something root 3.
Yeah, let's change that to something root 3.
8 root of 3.
Let's change that to 8 root of 3. Very good. Therefore, what would the radius of this? I just changed that to make the problem work, okay? It'll still work, but the numbers will come out worse. So what does this side have to be?
8.
That has to be 8, because this over here would have to be a 30-degree angle, right? So if this is 8 root 3, to go, this is the long leg, right? This is the hypotenuse over here, correct? Okay? So that's the long leg of the right triangle. This is, and this is the short leg, so it's 8. So now let's think about how would I find the area? I have to subtract something from something. How would I do that?
Well, you take
Go ahead, Charlie.
find the area of the sector and then subtract the sector from the area of the triangle.
The area of the kite, right? Twice. Very good. So what Charlie said is correct. You have to find the area of the sector right here, the piece of the pie, and subtract it from the area of these two triangles. So the area of one of those triangles would be 8 root 3 times what?
8.
Times 8. Because if it's a right triangle, this times this, you can multiply together the two sides that are perpendicular to each other. So the area of one of those triangles is 8 root 3 times 8. But how many of those triangles do I have?
2.
2.
So you don't have to divide by 2.
Right, minus minus the area of the sector, which is, I have 120 degrees. I have 1/3 of pi times 8 squared. Do you guys see where I got that from? 1/3 is 120. They got that because you have 120 3/60, right, of the circle. It's n over 360, because to find the area of this shaded part, it'd be n over 360 times pi r squared. So if I just subtract this sector from these two triangles, I will have the shaded area. So it's kind of complicated, and like Charlie said, these cancel out, and I get 64 root of 3 minus 1/3 of 64 pi. 64 pi divided by 3. And that would be a nice exact answer. And that you would read that as inches squared.
So that's the answer.
That would be the answer. You could put it into your calculator, round to the nearest tenth, but this would be the nice, neatest answer. Okay? That's kind of a tricky one. So in this section, they're kind of tricky. I'm just going to do a couple more. Let's do this one. Say you have a, can I move on?
Yep. Yeah.
Okay. Say you have a circle, 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 circle. Shut up, whispering. Circle. And then inside the circle, you have a triangle. I don't want it to be dotted. That where the hypotenuse of the triangle is actually a, wait, did I draw this right? I'm looking, yeah, that's right. It doesn't look like it. Well, let's pretend, oh, that's not that bad. So this goes through the center of the circle. This is a right triangle. And they tell you something, that this side is 8, that this side is 6, and they want you to find the shaded area again. So find this, let's make it yellow. Yellow. They say find the shaded area. Could you do that?
Yeah.
How?
You take the area of the circle minus.
Yeah, so you find the area of the triangle. So in this case, what you want to do is find the circle minus the triangle, right? Circle minus triangle. So in order to find the circle, what do I have to do?
Find the radius.
Find the radius. How do I find the radius?
Find the hypotenuse.
I find this Pythagorean theorem, right? So 6 squared plus 8 squared equals c squared. 36 plus 64 equals c squared. So c equals the square root of 100, which is equal to 10, which must mean that the radius is equal to 5. Right? So this here is 5. So the area of the circle is pi times 5 squared. And the area of the triangle is what? 6 times 8 divided by 2, which is 25 pi minus 24. And that's your answer. If it's in square meters, you write it in square meter. If it's in square inches, whatever the units happen. Okay? I'm going to let you figure out some of these other ones. Except for, this is like the famous problem that they like to do. You ready? This is like number 7 on your homework. Let's look at number 7. Can we look at number 7?
Yeah.
Okay. What does number 7 say? I could look up the book. Wait, we have to pause. How do we pause? Sorry.